in this field because I do believe it is the key to opportunity and power in their future. Whether you want to own a yoga studio or be a professional basketball player, it doesn't matter. Technology is going to be create and manipulate that technology. You're going to have power. So I always kind of think computer science is the key to opportunity in that way.
Awesome. Yeah, absolutely. I appreciate you sharing. Thanks, Annie. Those make really good sense, those things that you mentioned. Who else? Feel free to just jump in. Love to hear from you.
I can go next because I have the key as well. I agree with what Annie was saying, and then I also was thinking of it as like the key that unlocks parts to their brain. Like we're helping them like unlock things that they didn't know, skills and potentials that they didn't know they possessed. And I lost my train of thought. It's kind of early, but that's what I'm going with so far. Sorry.
Nope, that makes good sense. I think the things that you've mentioned are really helpful. Yeah, thanks.
I can go next. I put mine next to the build your own menu board. And I just think for the discussions that we had yesterday, it seems like everybody's kind of in a different type of role, whether you're just a general classroom teacher or you're a music teacher or you know, you have a different role within the school. I think everything can kind of be tailored, and I think the discussions yesterday showed us that there are many different ways that we can integrate computer science into education, and we just need to find something that works for us and our teaching styles and the situations that we're in. So that is why I chose that one.
Absolutely. Yeah, appreciate you sharing that.
I also did the build your own. For me, you know, going to co-teach with some teachers that have never had a computer science experience before, getting them on board was this way, like saying like, we're going to give you a menu of options and you're going to be able to pick, we're going to be able to pick and choose together which one's going to fit with your curriculum. I think it's the best way to get other content areas on board. Because they know you're not taking over their curriculum or trying to be the expert in their curriculum, but giving them opportunities to integrate as a build your own kind of thing has been pretty cool.
Yeah, great insights. Thanks for sharing that. I think considering the viewpoints of the cooperating teacher is important, definitely.
And I also chose the build your own menu. I was thinking about it in the terms of how I like to present a buffet of options to the kids. I want them to always be able to have something they feel comfortable with showing me their learning. And I think the computer science and all the tools that go with it could be that. And I try to keep that yes in mind when a kid says, can I do blah, blah, blah and this way? Yes. if at the end goal is you will show me what I'm asking for, yes. It's, you know, so I was thinking about that with the menu of options.
Absolutely, that makes really good sense. I love this kind of student voice and choice piece, yeah.
Yeah, I was also thinking of the choice menu board, just how that relates to giving students choice. And I was just even thinking about, you know, even in this course, there'll be likely tasks given and there'll be products made in a variety of different ways, but they're all accomplishing something that we're trying to get done.
Yeah, absolutely. Kind of that common theme, right? Where we're maybe starting with a similar idea and then taking it to wherever our imaginations and where our necessity lies, right? For sure. How about anyone from either the onion or the flower?
I can do the flower. So I chose the flower and the bee. There's a couple different ways I was thinking of. The first one is the child is the bee, and the flowers are all the different content areas, and the bee moves from flower to flower, and the child is getting computer science and math and reading, blah, blah, blah. Or I was thinking it could also be the child being a bee again, but the flower is the teacher, and the child is coming to the teacher to get all that different knowledge, and all the flowers are its teachers during its lifetime. So that was my way of thinking it.
Love it. Yeah, that idea of kind of cross-pollination, and whether it's the teacher or the content areas and the student kind of gaining from those or feeling kind of empowered and enriched from those is really, that's a cool image. I appreciate that.
I chose the onion, and like Annie said, each picture I could, get some kind of a meaning from it. But I thought of the onion as like, the layers of the onion, and there's so many layers to coding computer science. And the further in the onion you go, the stronger it gets. And so as we kind of peel back those layers, the stronger our depth and our understanding becomes in that content.
Yeah, absolutely. I think that was really well said, for sure.
I was also the onion, and I think I just chose it because I like the layers, and I like thinking about how, as you kind of, I think it can be hard to get into those deeper sort of, sometimes it can seem really easy to do some of the top layer things, and it feels meaningful, but then it's like the further you go, the more you can kind of integrate in a more meaningful way.
Yeah, absolutely. I noticed nobody said anything about crying with the onion, which is good. Yeah, I appreciate the sharing here. Would anybody else want to share? Don't want to cut anybody off here. All right, well, I would agree. I think there is no wrong answer here, and it's just so kind of cool and exciting to hear from a variety of perspectives where integrating computer science and computer science more broadly really resonates and holds meaning and value. We'll kind of keep these in mind as we forge on, and just invite kind of that differing perspective and also the connection to kind of other things and to outside concepts as we continue to kind of wrestle with what CS integration looks like and how the best ways are to implement that. So wanted to give you just a little bit of an overview of what we have going on today. Let me get to the right tab and I can share my screen again real quick. So in our live sessions, as we mentioned yesterday, we've got kind of a set agenda that we like to follow, where we try to really engage one another in some sharing, collaboration, and discussion. Part of our sharing today was really around your interpretation of CS integration, that kind of first activity we just did. Then we also want to open it up to hear from you about any reflections after day one, hearing about how things went as you maybe started taking a look at some of the asynchronous content on our Canvas course. If you had any thoughts or reflections later on about the foundational practices that we mentioned, whether it's the equitable teaching practices, computational thinking, or sort of that engineering design continuum from the Science Museum of Minnesota, we'd just love to welcome your thoughts about that in just a moment. We have kind of a virtual collaborate activity here, something that I learned about from the folks here on this call, the Bloomington folks, Lego Duck Challenge, and then something that I continued to read into more and adapted for a virtual setting. So wanted to just engage us in that for a little bit as a fun way to collaborate with one another. And then we have a discussion where we'll get to explore some different computer science and content integration examples. And then the word that's missing there after the semicolon is reflect. So we'll explore and reflect. We do have office hours today from 1 to 2, totally open, just a chance to drop in and ask questions, or if you're excited about something to share out, we welcome that for sure. Asynchronously, we'll be digging further into some levels of computer science integration. We'll look at a couple of case studies and kind of ask for your interpretations of those. we will do a create task where you're kind of stepping one step further into your own kind of integration project by identifying the means that you'll use to integrate and kind of finding those direct areas of overlap between computer science and the content area that you're focusing on. And then again, we'll have the opportunity to reflect, where you'll just choose one of the reflection questions from your design journal. And that's kind of the overview of day 2 for this course. Again, just to reiterate, no pressure at all to finish this by today. This is just the way that we're chunking the content. You have up to 2 weeks after the end of this week, so I think it's August 7th, to complete all the content for feedback and CEUs. So no pressure to get this done today, but that's kind of what we've laid out in the day 2 segment for today. Any questions or comments about today, about the content we've got in store? Tom, anything else to add?
No, not much to add, just that, looking at the progression of the course and where we're kind of heading. Yesterday was kind of thinking about the small pieces of your unit, like the standards and things, breaking those apart. Today we're kind of trying to start to put some of those pieces together in an intentional way to really kind of set the course for your unit or project. So thinking through like where those pieces overlap, how they can connect, where you really want them to fit in your unit and why. So just thinking about big picture, that's kind of the progression of where we're trying to head here as we design our own content integration units.
Absolutely. So at this time, we want to go ahead and move into our sharing portion. We'd just love to hear from you. I'll kind of flip through these first slides that just kind of give us a little visual reminder of some of those foundational practices. We've got these equitable teaching practices, really thinking about making it matter, ways that we're building student confidence and professional identity in computer science, and ways that we're really creating and growing an inclusive community within our classrooms. So just wanting to call out or invite you to call out anything that continues to resonate with you, any thoughts that you had after the fact about any of these, and or any reflections after your engagement with day 1 content. So just kind of want to open it up for you. And I'm going to stop sharing my screen so we can see one another as we're sharing.
Okay, I can go.
Sure, thanks, Hannah.
I came yesterday thinking that integrating computer science with music is going to be extremely hard. But after hearing other people and other ways that they have integrated music, either like using Scratch or code.org, I think it'll actually be easy and it'll be fun. And I'm excited now after hearing all the different ways that people have used music and computer science together.
Yay, that's awesome. I'm glad that feels like it was a help, and glad that you feel supported by examples shared. That's awesome. That's really, I think, exactly what we're hoping for with this course, so we can all help and support one another. Thanks for sharing.
I'll piggyback off of that. My goal was to work on some integration for 6th grade health, and health to me is like body parts, and I did not see a clear integration in my mind, but actually it's taking the time. I know you guys kind of prepped us like standards dive is kind of dry, but it was so necessary because when I actually like dug into the health standards, I'm not a health teacher, so that was new for me, and dug into the computer science standards, I have like 4 ideas that I'm really excited about. So it was a really like good day for me in terms of just like getting excited. I haven't like put all the pieces together yet, but I've got some vision of where to go, so that feels really good. And I thought health was going to be hard, and just like music, now I'm feeling like, oh no, I can do this. Sorry,
That's-
excuse the noise.
No worries. We totally get it. Yeah. No, thanks for sharing that. I think there is so much power behind looking at those standards. And yeah, even though as Tom and I were prepping this course, we're like, oh my gosh, are we really going to have them unpack standards? That sounds so boring. But really, I think when we get to the meat of what we want students to learn, of course, like those standards are what helps drive our vision and our direction. And then it's the art of teaching that brings those to life. And so I think having those in mind is really important as we go forward. And I'm so glad, Annie, that you found connections and that helped inspire ideas. That's really awesome. Others who want to share?
I appreciate the unpacking the standards activity yesterday, because in my role, I serve many different schools. I serve 23 different elementary schools in our area. And I'm not a traditional classroom teacher. So kind of gaining that perspective that classroom teachers have will, I think, allow me to be a more valuable resource for those teachers when talking about integrating computer science and just having that understanding of things. I think it's easy to forget how important some of those standards are and how much pressure some of those teachers have to teach to those standards. So I thought that was really valuable.
That's awesome. Yeah, absolutely. Thank you for sharing that. I think I'm in a coaching role this year. I have been for the last, I guess, year and a half or 2 years, and just thinking about kind of going back into that classroom teacher mindset, it definitely is so important as we're designing curriculum and remembering how is this sustainable, kind of keeping in mind how is this sustainable and how is this scalable? Because we're maybe doing this for one lesson or one project here. Now thinking about how does that play out for a classroom teacher who's got, especially in elementary, who's got like, 7 different courses that they're teaching, 7 different content areas, and then, not to mention every day a different thing. So really keeping in mind the sustainability and scalability, and also what supports will be needed, I think is really important. So I definitely appreciate you sharing that. Anybody else, reflections or connections or questions that came up? All right, well, of course, we always welcome your reflections and connections. The chat is open. We invite those as we continue on through our live call this morning, and then on our discussion boards on our Canvas course. Just continue to invite you to share things there as you would like, as you feel led. We're gonna move on now to our Collaborate activity. This activity is really at its core just a really fun one. When I think about the play, tinker, make, engineer continuum, this to me feels like a playful tinkering, I think, but could be catered then into more of a making or engineering as next steps. And so this activity was introduced to me by our Bloomington friends on the call, Annie and Whitney, and as we went into classrooms to do this activity, something that just really struck me was how much fun kids really had engaging with kind of hands-on tinkering, and then the connections that they made afterwards. I don't know, Annie or Whitney, sorry to put you on the spot, if you have any other insights you want to share about this, kind of the why behind this challenge, or anything you noticed when you were doing it with students.
I'll just, to give a little context, with our computer science immersion students, we did, Whitney and I, like the first or second day of school. So the kids are like new to their teachers and new to everything, came in and we were like, hey, we're teaching you computer science this year. And this was the first activity that we did. So the kids didn't really, this was like kind of how we like introduce the word computer science to them. And it's also how we introduce it to our teachers. So any teachers who go through professional development with us, this is the very first activity they do on the very first day. So we love it as a way to show computer science is we're going to introduce it to you without a computer. I mean, I know this way will be a little bit different, but get them super excited. And collaboration is kind of the exemplar that really gets amplified in this activity too. And I'm super excited to see how you made this for distance learning, Andrea. Can't wait to steal however you did this.
Yeah, I figured this could be mutually beneficial. So this idea also, as I was reading up about it, came from a blog called Coffee for the Brain. He's got kind of his whole layout there of how he introduced it with students and kind of the next steps and different things. Today, as we're working on it, I'd be curious, kind of in light of our unpacking of standards and things like that, just any connections that you're seeing with content areas and or CS concepts. So keep that in the back of your mind while tinkering and playing and then collaborating. So here's how this challenge works. Our task is to, in a limited amount of time, create a Lego duck. I'm going to share a link with you to a virtual Lego playground, and I'll give you 1 minute to just play around with that playground. Oh yeah, coffee for the brain. Here, I'll share my screen so you can see it. Here we go, application, here we go.
But don't look at the website until we've done the activity. Just
yeah, maybe don't spoil the surprise. All right, so here we go. Lego Duck Challenge. So we're going to engage with a virtual Lego environment. I will give you 1 minute to play around with it, and I'll show you now kind of how that environment works. But I just want you to have a chance to play around with it, just kind of create random things or just see how it works. And then I'll give you 2 minutes to create your Lego duck. And it's really important that everybody sticks with your 2 minutes. After that 2 minutes is up, I've created a slide on our Jamboard where you can share a screenshot of your Lego duck. So once you go to our Jamboard, it's just slide 2. It just says share a screenshot of your Lego duck here. This side where it says remix, try not to post anything over here because we'll use that when we do kind of our next iteration. So here's the virtual Lego environment. And you can see that over on the left, there are different types of bricks. When you click on them, they populate here. All you have to do in order to use a piece over here is click, and then I'm not dragging, I'm just kind of hovering my mouse, and then you click on the spot where you want it. So I'm just kind of clicking. And if you need to undo something, you can click undo. If it's bothering you that the grid continues expanding, you can click stop placement. And you can always clear your board. For me, the easiest way to clear is just go to apps and brick builder, and then it just loads a new page for you. Okay, so I'm going to give you 1 minute to play around with this brick builder here. And then I'll let you know when it's time to start the Lego duck portion. And really, ducks are completely open to interpretation here. We're not testing your artistic ability. We're not testing your modeling ability. Just want to give you a chance to create a duck in your own mind's eye. Okay, so let me paste a link directly to this Lego virtual environment and the slideshow in the chat. Yep, we'll paste the slideshow. So here's the virtual environment for Legos, and the slideshow is in this. Okay, so I'm starting my 1 minute timer. This is your time to just play around, just explore that brick builder. And I'll let you know when it's time to switch gears. All right, that's our 1 minute timer. So at this time, go up to apps and select Brick Builder in order to clear your screen. And I'm going to start our 2 minute timer where you can create a duck in any way that you'd like. Ready? Go ahead. All right, that's our 2 minute timer. So go ahead and stop. I'm going to paste the link to our Jamboard back in the chat. If you wouldn't mind taking a screenshot of your duck and adding it to the Jamboard. The add photo kind of icon is just below the add sticky note icon. And no need to add your name or anything unless you'd like to. I guess we won't cut you off from that if you're interested. But curious to see the variety of ducks. And again, that's on the second page of our Jamboard. And as the Lego ducks are populating here, just curious to find similarities, to find differences. Be interested to kind of hear about your process. Some good guiding questions with students are, what do you notice? What do you wonder? I'll share my screen too so we've got a good view of things as they're happening. All right, well, as the photos or the images are populating, we'd just love to hear from a few people. What's coming up for you? What do you notice? What do you wonder? What's kind of a reflection of your process? How did that go? Where is your mind at right now?
I like how there's a difference between like 2-dimensional and 3-dimensional ducks. Like there were no constraints put on what you were supposed to do, so we just got a variety of like lots of creative and different interpretations, which is really fun to see.
Absolutely. Yeah, thanks for sharing that. So
My daughter here pointed to only a couple and said duck. So some of you passed the test. I did not. Yeah, I feel like I was totally I struggled because I've done the physical one. I was just trying to replicate what I've done with the physical one rather than like opening my mind to the new possibilities given this new environment. So I'm like looking at these like, oh my gosh, yeah, I should have done that and I should have done that. So it's cool to see what people did.
Yeah, I mean, Annie, since you mentioned the kind of the original or the physical Lego Duck Challenge, what I forgot to mention is that in that original challenge, each person gets the exact same 6 Legos. So you have kind of that as an additional constraint. This time, I wanted to keep it open because I figured it's a new virtual environment for us all, and we were all sort of limited or constrained in which blocks were offered. So that was one adaptation. Other thoughts or reflections?
Personally, as I was working through this, I thought the time limit was pretty challenging. Like, I think in my head, there's, an idea I wanted to try to go for, but then I'm like, okay, I have like 90 seconds to do this. How can we possibly do? So it's kind of that balance of, ideas that you had in your head and also trying to make it fit in the time. So I thought that part was pretty challenging.
Yeah, and in the original challenge, we only give 1 minute in the physical challenge. So I extended it to 2 minutes, knowing that sometimes with technology, there are glitches that go beyond just what you can tangibly work with. So 2 minutes was more than the original 1 minute, and it still felt tight. Yeah, thanks for sharing that.
So I noticed that since I've already done this, I was really stuck the same as Annie was saying, like in what a duck should look like or what the Lego duck that I thought of should look like. And so now I see that, of course, everyone's is different and everyone chose different colors in 2D versus 3D. It made me think of when we did this, Annie can probably talk more to this, but they couldn't find the yellow Lego duck colors. So we had to do it as a swan challenge. And a lot of our students didn't know what a swan was. So I had to show them pictures of swans. And now I'm thinking, like, was I actually doing them a disservice? Because when I look at all of our ducks, like, these aren't what I think of as traditional ducks, but obviously other people do. So, like, should I not have shown them what swans were? I don't know. So it's kind of like triggering new things in my brain now.
Yeah, thanks for sharing that.
I know it's kind of starting to make me worry, like why can't I imagine what a duck looks like? I don't know, I'm starting to think too much now about why I made what I made. It's pretty funny.
Well, something kind of computer science connection-y is when we think about abstraction, oftentimes, abstraction is kind of the idea of abstracting away unnecessary details to just focus in on the most important parts. And we could definitely kind of create a list of, from our examples here that we created, what are the things that we think of when we think of a duck? It looks like most of us think of a beak or a bill of some kind. Looks like many of us think of, what else we have in common? I guess a head and eyes. Many of us had a tail, but not everybody. So just kind of creating conversation, almost like a math talk, but a computer science talk, creating conversation around the idea of abstraction and how we've had to abstract away unnecessary details because we didn't have everything we needed, given to us. And so finding those areas of commonalities and the areas of difference, because, sometimes those really out of left field or those really different, the sort of outliers answers are some of the most creative and have some of the best reasoning behind them. Like, not to call anybody out, but I'd be curious, anybody who did a duck that doesn't maybe look like everybody else's duck, would you be willing to share just kind of what your thought process was?
Mine looks different, not by design, but more by the fact that I was trying to figure out how to make sure bricks were going above each other or below each other. And so I don't know if mine was intentionally looking any different than anyone else's by my original design, but just by the nature of trying to figure out the tool itself a little bit.
Yeah, absolutely. That plays into any activity like this for sure.
Yeah, mine needs a little bit of cosmetic surgery on the bill itself.
That's okay. That's okay. This is the first iteration. No worries. Something else that we point out in kind of that original tangible challenge and that I think holds true here is no matter how many times we've done this challenge, we've not seen anyone come up with the exact same duck. And that's really unique too, and just goes to the idea of the importance of multiple perspectives, and that we all have our own viewpoints and our own perspectives, and those serve to enrich our understanding of the concept or the content at hand. And I think this is a kind of a fun, playful way to edge into that important conversation about the value of all of our perspectives and all of our voices in our computer science class. With that, I'd like to take us into just our next level. So this is where the collaboration aspect comes in. So you'll see that over here it says remix. Share screenshots of your remixed Lego ducks here. What's going to happen next is we're going to put you into just breakout rooms of 2 people, 2 to 3 people. And what we'd like to invite you to do is for 3 minutes, we're going to give you a chance to create as many ducks as you can. I hope you didn't erase your duck from your screen, from your brick builder. If you did, that's okay. You can use the Jamboard to kind of point it out. But gaining ideas from one another, and then remixing and creating as many new ducks as you can through communication and collaboration with one another. Sometimes how this looks is it looks like, oh yeah, my duck had, you know, a tail. Did yours have a tail? No. Okay, let's create one together that has a tail and maybe another aspect of what yours had. So including conversation that brings together the ideas that each individual person had and creating something brand new. So again, this is kind of taking our Lego Duck Challenge into the remix territory, and then we'd invite you to share those as best you can. We'll jam them all into this, this other half of the sheet here, and just kind of curious to see, we're gonna give ourselves, you know what, I had originally said 3 minutes, but we're gonna stick with 2 minutes. We're gonna give ourselves only 2 minutes to create, and then we'll share back there, and we'll just see if the volume of ducks that we can create when working together is more than what we could create alone. All right, so I'm going to put us into random breakout groups of 2 each. You've got the link to the Lego Brick Builder, you've got the link to the Jamboard, and we'll see each other back here in about 2 minutes or so. Any questions? All right, we'll see you back in a little bit. All right, welcome back. I can share my screen again. Would love to hear from groups about how that went, initial reflections, any remix tips that worked really well, anything that you wish or would do differently next time.
It was really hard for us to not see each other's ducks. Like, when you do this in person and you're sitting at a table together, you're seeing each other's ducks. So one person was able to share their screen and then the others could see theirs, but we couldn't see everybody's ducks at the same time. So, and we probably could have gotten creative and been like screenshotting them immediately and dropping them into a shared place or something, but we didn't get that far.
Yeah, time didn't allow for that. So I don't blame you in the least. We found that as well in our group, that it was hard not to be able to see one another's ducks, and kind of the communication became incredibly important. How about other groups? What did you think? How did it go? Easier or harder than the first time?
I found it a lot more challenging because I was trying to incorporate so many components of the other ducks that I really didn't know what to do. I just kept trying things and it wasn't working out. And so then it's like, actually my duck now looks more like a dog and nothing like a duck at all.
Yeah, and kind of similar to that, I found myself kind of comparing my own duck now to what I knew others looked like. The first time I had no idea what other people were creating, so I was, really happy with my duck. And now this time I was like, oh, well, it doesn't quite look like I wanted it to, like that one did or that one did. So just kind of an interesting comparison going on that didn't happen the first time.
I think we were all new to that program, and so we just mainly shared what we learned in using the program to create the duck, and that sort of helped me, not that it looks any better, but try some new things out just in the software.
Absolutely.
We got stuck telling our California friend what a gray duck was and why that's so funny for Minnesota.
That's totally legit as well.
I think that was me. I had no clue.
I know, Brian.
Hey, that's great. That's great. We're learning all sorts of things from one another today. Something I notice as I look at the ducks on the right side is the complexity of some of them is more than what was present in the first or on the left side, at least on a couple of them. And it's definitely not a dig against any of them on the left side. I think the complexity was awesome on the first ones, but just noticing a couple where, there are multiple levels and really intentionality about kind of the placement of things. And again, nothing against the left side, but that's just something that maybe is jumping out to me from my own perspective. Like, I'm curious, there's one that has a wheel in it. Like the creativity maybe is, creativity and complexity is maybe taking a step further. I don't know.
I'm the one who had the wheel, but I think our group was doing a slightly different version of this activity where we were trying to make as many ducks as possible within the time. Is that what you were? I'm sorry, because we got confused about the assignment, honestly.
Yeah, that was the original idea, was to see how many we could create. And then I think like once I got in with my group, the communication part was, almost took over. And it was like, well, never mind creating so many. Let's see if we can even create one together that we really like. It's almost like the challenge morphed as we were in it.
And then I'm trying to remember. Oh, Annie was explaining that in person, you would have a group of students and they would be making like as many little Lego ducks as they could, and they would be based on other people's ideas. Is that kind of how it works if you were actually in person with Legos?
Mm-hmm. Right, yep.
So yeah, basically this is how far I got, this little one in the top left, and then my screen froze. So I was just like, okay, take a screenshot.
Process pictures are important too. I think like when we talk to students about whatever we're creating, it's important to recognize that every step in the process is an important thing. So no shame for getting a process photo for sure. Any connections that you can draw between this challenge and computer science concepts or thinking about content concepts? How could you use this with students? Where would this potentially fit in?
For us, when we do it, it really showcases that everyone brings their own perspectives to the table and that there's no right or wrong answer. I mean, certainly I look at some of these ducks and I'm like, oh, that one's cool. That's better than mine. But really, like, they're all wrong in some ways and they're all right in some ways. And so it really, as our first introduction to computer science, we just kind of say everyone's coming into this with different backgrounds and we welcome all of you. And there's a place for all of you in computer science. But then it also, we were kind of saying in our group, what ends up happening when we do it face to face is that the kids, they struggle to put a duck together put one duck together in 2 minutes. But then when you let them try again, they end up like a single kid, if they're able to collaborate, can in 2 minutes, we've had kids come up with about 8 different ducks in 2 minutes. And that's when they're able to collaborate. So then we introduce the idea of like, we have better ideas and more creative ideas when we get to use each other's ideas. And so this idea of remixing is going to be really important in computer science. So those are kind of the two, collaboration and then multiple perspectives are really the two pieces we pull out from this activity.
As an introductory activity too, I think I like hearing what Annie is describing because it makes me think this is a good opportunity for teachers to set up routines and procedures for kids as like a first activity. And then also to do some process monitoring around equity of voice. You can get a lot of information around like when kids are collaborating on projects about, hey, does everybody have equal voice and do we need to have a discussion about this and how we actually do collaborate with some equity. So this is really powerful, I think, speaking about that to me.
I think for younger learners too, if you go back to that, like what you put on slide 6 with the computational thinkers, there's concepts like abstraction, which can be very hard to help kids understand. But if you can talk about the fact that you're looking for, what are those main things that we're trying to make about a duck, and kind of stripping down all the extra details, but what are the main things? So I think it's a nice way to kind of bring them back at the end in reflection to some of those computational thinking concepts and just vocabulary, and kind of put some more meat on the bones to help them figure out what those things really mean.
Yeah, I really like the connection to abstraction. And I also think like there's a way that you could continue to use this activity to talk about algorithms by writing an algorithm for someone else to create a duck or some other object with this program. And I mean, I bet some of you have seen or used activities where you're like describing how to make a Lego structure to someone else without them seeing it, or you're giving them instructions. I feel like you could use this for that kind of activity.
I think you could increase the rigor and the complexity of it too by saying, okay, a new duck would count as one thing changed. Well, that's pretty easy because you could change one brick and multiple times and make multiple ducks pretty quickly. But if you upped it by saying you have to change at least 2 things before it to count as a brand new duck, or you have to change 3 things. And that's some computational thinking too. And some kids, because I know some kids would key in on I can just change one thing and make 18 ducks pretty quick. But if you force that other iterative process into it, that could change the game a lot too.
Yeah, I appreciate those reflections. This was the first time that we've done the remix part of this one as a virtual activity. We had done the just the share your own Lego duck challenge before. I did that actually in a CSTA presentation that I gave last week. And that part went off really well. So I was curious to see how the collaborative remix part went, because it is so powerful and also like brings on kind of so many new ideas and invites in kind of the how can I use what you did kind of idea. But I think
like from my own perspective, what I would do differently next time, I would allow a lot more time for the remix, because online collaboration takes more, like more intentionality, because of what Annie mentioned about having, not being able to see one another's Lego ducks. So kind of going forward, that's something that I'll take into account for sure. And maybe having some structures for the conversations as well. I love the idea that you just shared, Allison, about like, let's have change one thing, change two things. Love that. Those parameters can be so helpful. Cool. Well, thank you for engaging in that collaborate activity. We will shift the discussion for tomorrow. We'll shift the discussion we had planned for today to tomorrow so that we make sure that we can cover that as well. Just a couple of quick housekeeping things, and then we'll be on our way. We have a CS glossary, concept glossary, that we have modified from previous activities that we've done and just kept adding to it. This is something you can make a copy of and add to your design journal. Just a quick glimpse at it. It has a variety of different CS kind of sub-concepts, is what the CSTA standards would call them. And then it also has some examples of that, and it has unplugged activities and some sample projects. So just wanted to kind of make that available to you. And also, looks like there's a blank slide at the beginning, but you can scroll down to slide 2 and see it in action there. But just wanted to make that available to you, and also let you know that you can, of course, when you make a copy, remix it as you see fit. A lot of these examples draw from Scratch and Microbit, because those were two of the courses that we're building, and so we wanted to make sure to include those. But of course, so many different you can take this in so many different directions. So wanted you to know that that is available to you. And it's linked directly through our slides here, but we'll also add it to our Canvas course. Tom, do you want to talk to us a little bit about our asynchronous learning for today? I know we're just 1 minute over. We're just about to wrap up.
Yeah, sure. Real quick. So like we mentioned, yesterday was kind of about identifying those smaller pieces, and today's all about kind of putting those pieces together in really intentional ways. We kind of have 2 things to learn about, so we called one of them a bonus. We're using Tomlinson's model for differentiation. Carol Tomlinson is like a guru in the world of differentiation, has a model that breaks things apart into content, process, product. So there's a kind of overview of that, because as we learn more about that, we can really understand where we want computer science integration to happen. Is it like in the content students are learning about, the process of the skills that the students are using, or the product that students are making? So we're kind of using that as like a guide for how to integrate, and then learning about different levels of integration from more surface level to deeper levels. And again, just really emphasizing that no right or wrong way to do it. It's not like going deeper is always better than staying more surface level, but just being aware of the differences there so we can be more intentional with our choices. And then for our create part, we're looking at step 2 of like our 3-step process. Today, we're really identifying how you're going to integrate those standards you broken apart yesterday, where that's going to be, and why. So that's kind of your asynchronous learning for today. And it is, again, don't feel pressure that you have to get it done by today, but it's just kind of a logical next step from the work that we started yesterday.
Awesome. And just a reminder, we've got optional office hours today. If you have any questions or run into any challenges, we'd love to be able to support you. And then we'll see you back for a live session again tomorrow at 8:30 if that works in your schedule. And that's it. We'll make sure that a recap is posted in our course, in our Canvas course. And then we'll see you again whenever it works for you. Thanks everybody for your time and your engagement today. We'll stick around here as well for a couple extra minutes if you need, if you have any questions or anything. Otherwise, we'll see you soon.
Thank you.
Thanks so much. Take care.
Thank you.
Bye.
Where are they going?
Bye.
Bye.
Hey, I have one question.
Sure, go ahead.
So we have Scratch with our PLTW teacher, which is a specialist class. How much more would it cost for our school to get it school-wide? Like, is it a lot more? Do you know? Or
Scratch is actually free.
oh, it is. Nice.
So it won't cost you anything. Yeah.
Okay. Woohoo! They were asking about that, and I was like, well, I'll see. Okay, so I could definitely use it for music then.
For sure you can. Yeah, for
One thing
sure.
you might want to check is if you're project lead the way teacher has accounts for the students. Like if they've already done Scratch with the students, they might have made accounts for the students. Then if you get that account information, you could have the students use those same accounts and use the same projects and everything they've been doing.